The most distant human-made object is NASA's Voyager 1 spacecraft, which has managed to reach interstellar space. Imagine launching a spacecraft 45 years ago, and it's still exploring areas it was never thought to reach, well beyond its scheduled lifespan. That's the incredible reality of a bold NASA mission that's redefining space exploration. But there's something even more fascinating. This brave spacecraft is not only billions of miles from its launch point, but it continues to send data back to Earth using technology older than a cassette player. That's not all. The spacecraft, launched in 1977, has just made a discovery that has shaken the scientific community and captured the attention of the entire world. What could this amazing find in the far reaches of space be, and what does it mean for us here on Earth? There was a key moment in history when two of the most amazing space missions ever launched ushered in the age of space exploration. It was thanks to the brilliant mind of Gary Flandreau of NASA's Jet Propulsion Laboratory that an ideal route was mapped out for a probe to reach the distant planets Jupiter, Saturn, Uranus, and Neptune with just a pencil and a 20th-century engineering tool. Flandreau made a startling discovery in the late 1970s and early 1980s. The four gas giants would be aligned in a unique cosmic configuration, creating a sort of celestial necklace with Earth. This would allow a spacecraft passing close to each planet to gain speed, thanks to its gravity, as if it were being pulled by an invisible rope. Thanks to these gravitational aids, a journey that would normally have taken 30 years from Earth to Neptune would be reduced to just 12 years. However, there was a catch. This alignment occurred only once every 176 years. Faced with such a rare opportunity, NASA acted quickly, and just 15 days apart, they launched two identical spacecraft, Voyager 1 and Voyager 2, in the summer of 1977, aiming to take advantage of this cosmic alignment. Little did they know then that these twin explorers would break all records in the history of space missions. More than 45 years after their launch, the Voyager 1 and Voyager 2 spacecraft are still operational, sending back information daily from the edges of our solar system. These probes have become the farthest spacecraft in history, having traveled far beyond what was first imagined, which is impressive when you consider that their original mission was planned to last only 4 years. However, these interstellar pioneers had many surprises in store. At the start of their epic journeys, they gave us incredible close-up images of the moons of Jupiter and Saturn, revealing worlds far more active and dynamic than had been anticipated. Discoveries of active volcanoes and ice fields forever changed our understanding of these distant corners of the solar system. Voyager 2, in particular, was the first spacecraft to approach Uranus in 1986 and Neptune in 1989, becoming the only probe to have visited those planets, surprising scientists with astonishing discoveries in previously unexplored territories. More than 14 billion kilometers from Earth, these Volkswagen Beetle-sized probes have defied all expectations and continue to expand the boundaries of our knowledge. Voyager's journey began with a gravity-assisted maneuver around Venus, a feat never before attempted by any spacecraft on its route to Mercury, making them true pioneers. The journey to Jupiter took the spacecraft 10 times the distance from Earth to Mercury and forced them to traverse the dangerous asteroid belt, a feat previously tackled by the Pioneer 10 and 11 probes. But the challenges didn't end there. With just 69 kilobytes of memory, a fraction of the capacity of a modern smartphone, the onboard computers had to rely on their own intelligence to manage the complexities of this extraordinary journey. Data collected by the Voyager instruments was stored on 8-track tape recorders before being transmitted to Earth via a transmitter that used just 23 watts, about the same power as a light bulb. The spacecraft were equipped with 12-meter diameter satellite dishes to facilitate communications. They used light-speed radio to send and receive messages, but the increasing distance from Earth in advance of 3 or 4 light seconds each day presented major challenges. Despite these obstacles, the Voyager probes have defied expectations and continue to amaze astronomers with unexpected discoveries in the interstellar void. Their journey has rewritten our understanding of the cosmos and altered our view of the unknown. Beyond our solar system lies the enigmatic Oort cloud, a vast congregation of comet-like objects held together by the sun's gravity and stretching out to the nearest star. Although the Voyagers are still moving slowly toward that distant realm, their entry into interstellar space began when they crossed the heliopause, the boundary between our solar system and interstellar space. Initially, this boundary was estimated to be about 50 astronomical units, AU from Earth, and so it was decided to continue funding the mission even as the probes approached that milestone. However, crossing this boundary did not immediately detect a change in the environment, leaving scientists baffled. The passage into interstellar space was expected to be accompanied by an abrupt increase in the number of cosmic rays, high-energy particles traveling at nearly the speed of light, ejected by supernovae and other cosmic phenomena. However, most of the high-energy rays are deflected by the magnetic shield generated by the heliosphere, which protects our solar system from most external threats. The Voyager mission team also closely monitored any changes in the prevailing magnetic field as the spacecraft moved into the interstellar medium, an environment composed of ionized gases and influenced by nearby stars. This interstellar magnetic field was expected to have a different orientation compared to that of the heliosphere. However, the Voyager probes did not detect any significant change in the magnetic field. It was on August 25, 2012, that Voyager 1 finally crossed the heliopause and transmitted fascinating data that confirmed the expected increase in plasma density, although without evidence of a change in the magnetic fields. This was surprising, since it had been anticipated that when passing from a region dominated by the solar magnetic field to one influenced by other stars, there would be a noticeable variation in the direction of the magnetic field. This puzzling finding generated an intense debate in the scientific community. If the magnetic field did not change significantly when crossing the heliopause, what was this telling us about the nature of the interstellar medium and the interaction of our solar system with its environment? Voyager 1, by entering this new region known as interstellar space, offered a direct window into a never-before-explored area, but also raised more questions than it answered. One early theory suggested that the interstellar magnetic field might be aligned in an unexpected way with the solar field, creating a smooth transition rather than an abrupt cutoff. This would imply that the forces shaping our cosmic neighborhood are more complex than we had imagined. The data also revealed a noticeable increase in high-energy cosmic ray particles from outside the solar system, confirming that Voyager 1 had officially left the protective bubble of solar influence, known as the heliosphere. But the mystery remained. If there was no marked change in the magnetic field, how far was the probe really from a region completely dominated by the interstellar medium? Some scientists speculated that there might be a more extensive transition zone than anticipated, a region where the effects of the sun still interact subtly with the interstellar environment. Others suggested that the heliopause might not be a clearly defined boundary, but rather a fuzzy border that varies depending on factors such as the solar cycle or the pressure exerted by the interstellar medium. As Voyager 1 continued its journey beyond the heliopause, the data it transmitted back to Earth defied long-held assumptions. Analysis of plasma density revealed unexpected fluctuations, hinting that interstellar space was far from the uniform vacuum once imagined. Rather than an endless expanse of homogeneity, this vast frontier appeared to be composed of pockets of plasma, each with distinct densities, temperatures, and energy levels. These findings puzzled scientists. Theoretical models had suggested that the interstellar medium should be relatively even, shaped over eons by the gentle but consistent pressure of stellar winds and cosmic radiation. Yet Voyager 1's instruments painted a different picture. Within a single week of observations, the probe detected shifts in plasma density that suggested it was navigating through regions of vastly different characteristics, some denser and hotter, others surprisingly sparse and cold. The variations were so stark that researchers began referring to these pockets as plasma clouds. Further study revealed that these clouds seemed to align with traces of ancient supernova remnants, suggesting that the interstellar medium might bear the imprint of catastrophic stellar events from millions of years ago. Each pocket could be a relic carrying clues about the violent history of our galaxy. Let me know your thoughts in the comments box. If you enjoyed the video, don't forget to hit the like button and subscribe to the channel.